Welcome to 6Win's vRouter webinar, where we will discuss our Brocade Vyatta vRouter replacement program and vRouter technology. My name is Eva Bonodo, and I will be your moderator for today's webinar. Joining me today are Kelly Leblanc, 6Win's VP of Marketing, and Yann Rapaport, 6Win's VP of Product Management. You can ask your questions using the Q&A button at the bottom of the page. We will answer them after the demo session. Finally, at the end of the webinar, we will announce the winner of our high-performance remote control car. Let's get started. I will now turn it over to Kelly.
Thank you, Eva. Hello, everyone. My name is Kelly LeBlanc, VP of Marketing for 6Win. Today, I'm going to introduce 6Win and our Brocade Vyatta vRouter replacement program. Then my colleague Yann Rapaport will show you a vRouter demo for one of our popular Turbo IPsec use cases. 6Wind is a software company headquartered in France with offices around the world, including Santa Clara, California, and Beijing, China. We make high-performance networking software with deep expertise in telecom. Our flagship product is vRouter software that has been deployed globally for over a decade. And for those of you from the developers community, you may know us as the founders of DPDK.org and a top contributor. In recognition of our innovation, we received an investment from Cisco and multiple awards, including NFV and VNF Products of the Year for our vRouter. Now for an introduction to our program to replace Brocade's Vyatta vRouters. Last year, Brocade announced the end of product and support for its Vyatta vRouters, and customers began contacting 6Win for alternatives. So we officially launched our replacement program for the Brocade Vyatta and VyOS vRouters last August. Customers simply fill out the evaluation form on our website, and a regional 6Win representative begins the process. Shortly following our program launch, growing network operators such as UVT Internet announced successful transitions to 6Win's vRouter. We were well prepared to transition these customers to 6Win's vRouters with our value proposition towards DPDK-based performance, features, and support. 6Win's vRouters are available in 3 different software packages for white box networking. The first is our 6Win Gate software, which is source code for Linux networking. 6Win Gate includes complete and modular layer 2 through 4 networking stacks. Here we help our OEM customers build their own vRouter technology and much more, including a full range of additional networking equipment and solutions. The second are software appliances called Turbo Router and Turbo IPsec. These vRouters are ready to run appliances for customers who build and operate networks. This will be the focus on today's webinar. The third is virtual infrastructure software for hypervisor networking. These vRouters boost virtual networking and switching performance inside NFV platforms such as Nuage Networks AVRS and Contron SIM Cloud. Our software runs on market-leading processors that leverage DPDK for performance, including x86 and ARM. We've been solving networking performance challenges for our network builder and OEM customers for over a decade now. Our customer list is impressive, with a large global reach, including servicing over 90% of 4G networks in Japan, the top service providers in the US and EMEA, and more. These customers use our software with standard tools such as Linux on commodity hardware to solve some of the largest networking challenges in the industry. For some examples, AT&T has been a 6Win vRouter technology customer for 5 years. AT&T uses 6Win's IPsec VPN software to create its virtual VPN internet gateway that creates secure VPN services for its customers. AT&T was an innovator to run this service in virtual machines versus deploying standard hardware. As a result, they reduced their CapEx by 70% and are now using the same technology within their new SD-WAN services as well. This second example is a Vyatta VyOS vRouter replacement. This is a large US DDoS protection company that runs a mission-critical private enterprise training network using vRouters instead of hardware routers. Its key requirements were performance and support. It ran dozens of VyOS vRouters in its network, and these VyOS vRouters couldn't handle over 1 gigabit per second of traffic. So this customer selected 6WIN's vRouters as their replacement and configured and sustained 5 gigabits per second each for routing and tunneling. As a result, this customer was able to significantly reduce its hardware costs through software. Now for more detailed product information on our vRouter appliances. 6WIN's Turbo appliances are scalable routing and IPsec VPN software for commercial off-the-shelf or COTS servers. Our Turbo appliances are available in 2 different software packages, Turbo Router and Turbo IPsec. For today's agenda, we will review features, performance, deployment scenarios, and management, and then Jan will conclude with our Turbo IPsec use case demo. 6WIN's vRouter is a full-featured software appliance, and here you can see an example of our Turbo IPsec appliance features. It can be deployed in bare metal and virtual machine configurations. It serves as an alternative to expensive hardware-based routers as it delivers the same traditional routing and security features with similar performance and both traditional and IT-style management. We have no interest in vendor lock-in. 6WIN's vRouter is open to any COTS server hardware that you select. 6WIN vRouter features include IPv4, IPv6 networking with support for VRFs, BGP, OSPF dynamic routing, tunneling, NAT, PPPoE and L2TP client server, ACLs, GRE, VLAN, VXLAN encapsulations, lag, high availability, and more. Our customers deploy 6WIN's vRouter as an edge router within public and private clouds, inside UCPE and BNG solutions, and more. IPsec VPN functionality is available through IPsec and IKE features. Customers that need secure tunnels and connections between sites, data centers, or mobile infrastructure are popular use case examples. 6WIN Turbo Router performance scales linearly with the number of cores deployed. Our software performance is impressive at 12 million packets per second per core on an x86 server. If you need more capacity, just add more processing cores to your configuration and enjoy similar performance, whether running bare metal or in VMs. 6WIN's Turbo IPsec software performance is impressive, and this is one of the reasons we've won so many NFV use case awards. We deliver 12 gigabits per second of throughput per core, up to 100,000 IPsec tunnels and 1,000 tunnels per second, all in software, and performance scales linearly with the numbers of cores. Customers who replaced Brocade Vyatta and VyOS vRouters with 6WIN vRouters report a 5x performance increase for IPsec VPNs with 6WIN while using only 1/3 of available hardware resources. Now for deployment options. Here we see 6WIN's vRouter deployed bare metal on COTS servers or within virtual machines. Within virtual machines, there are 3 options with varying levels of performance. The first is on top of standard open source hypervisor infrastructure using Open vSwitch or Linux Bridge with hypervisor options including Linux KVM and VMware ESXi. The second leverages hypervisor bypass technologies such as SRIOV or PCI pass-through with dedicated hardware resources to virtual machines for the highest performance. but this loses some of the benefits of virtualization, such as live migration. The third runs on top of 6Win's Virtual Accelerator vRouter in the Linux KVM hypervisor domain for the best NFV-ready performance, with zero hardware dependence. Performance is close to bare metal, and virtualization features are preserved. We give you these 3 deployment options so you can make incremental software upgrades for your cloud transition. Remember, it's the same 6Win software for bare metal or virtual deployments. 6Win vRouter provides both traditional CLI-based management and IT-style management based on automation and integration with high-level orchestration tools. For this, 6Win vRouter proposes Yang-based netconf and REST APIs. We also support standard Linux APIs such as IProute and iptables. Configuration can happen through Linux, the CLI, and APIs for integration with third-party management tools and orchestrators. Our data models leverage Yang and are therefore easily understandable and extensible. For deployment, we provide packaged images for bare metal, KVM, VMware, and AWS, and leverage the Linux Cloud Init features that enable the customization of day one configuration at startup, including initial networking configuration, default users, custom software packages, and configuration files. Finally, for monitoring, we support the traditional SNMP and syslog mechanisms, plus telemetry through SFlow and graphical analytics with time series database. We have pre-integrated the vRouter with InfluxDB and Grafana, which are standard open source time series database and analytics software. Our integration and default Grafana dashboards are available on GitHub for the community to download and extend. Now I will turn it over to Jan for the Turbo IPsec use case demo.
Thank you, Kelly. So in this demo, we will focus on Turbo IPsec and review the case of a secure, scalable, and cost-effective site-to-site VPN between enterprise locations. The traffic flows clear inside the enterprise sites and is secured using IPsec when going over the internet between sites. This is performed by a secure gateway sitting on the edge of each site and composed of 2 redundant 6Win Turbo IPsec appliances. Let's review the test configuration. Our platform consists in 2 single-socket Intel servers equipped with Intel Xeon E5 2680V4 CPUs with 14 cores, 4 10-gig ports on the LAN side, and 1 100-gig port on the WAN side. Turbo IPsec is installed on the servers and configured to use 8 cores for the data plane, performing IPsec with VRFs, IP in IP encapsulation, and ACLs. In this first performance test, we will measure the throughput through a single IPsec tunnel with all these features active. This is the Ixia traffic generator user interface, where we see the configured traffic items on the top and throughput gauges on the bottom. Clear traffic is injected into the first security gateway. It is encrypted and sent to the second security gateway, where it gets decrypted and forwarded in clear back to the Ixia. Let's start traffic generation. We see a throughput of 16 gigabit per second over 1 tunnel. Let's now switch to multiple tunnels and see how performance scales. This is the Grafana user interface, which is the analytics front end we have chosen for this demo. But remember, we are compatible with any analytics user interface of your choice. On the top left, there are the gauges indicating throughput on the 100 gig ports, and the same information is seen on the top right as a curve, with transmit traffic above the horizontal line and receive traffic below. CPU usage is represented in the bottom half of the screen, with Linux CPUs on the left and data plane CPUs on the right. We start traffic generation and check the gauges on the 100 gig ports, the network throughput curve and CPU usage. The aggregated throughput is 56 gigabit per second. The data plane is running on 8 CPUs, so this translates to 7 gigabit per second per core. Remember that IPsec, VRFs, IP in IP, and ACLs are involved in packet processing. We can see the data plane CPUs are used at 100%, whereas the Linux CPUs are almost idle. Now, let's have a look at the features used in this demo to ensure security and resiliency. Each site features 2 redundant Turbo IPsec appliances working in active standby mode. Let's zoom on the active security gateway on site A. It is configured with 2 VRFs to isolate traffic coming from the public network. Incoming IPsec packets are decrypted, provided they have been encrypted with the right secret, and forwarded in clear to the private network. Clear packets coming from the public network are dropped by our ACLs. For resiliency, HA is provided first inside each security gateway at the port level by using link aggregation on top of 2 different physical ports. If a link fails, the IPsec tunnels are redistributed on top of the other link without any traffic interruption. At system level, we combine VRRP and IPsec HA. VRRP is configured on each side between the active and standby security gateways. When one security gateway fails, this is detected and HA activity swap is automatically triggered. Thanks to the Turbo IPsec HA mechanism, IPsec tunnels are already pre-configured on the formerly standby newly active security gateway, and traffic flows without any interruption. Let's now see a demo of these HA mechanisms. On this screen, we can see the Ixia speedometers on the bottom left of the screen, indicating an overall throughput of 17 gigabit per second. Grafana monitors the active security gateway, and we see the throughput on the different network interfaces. At some point, the security gateway fails. We see the traffic throughput on the security gateway drop to 0, but we can see the Ixia gauges are steady. Let's switch to the other security gateway in Grafana. We can see it has actually seamlessly taken over the traffic. Now, let's switch to a live demo of our management interface. We will see in a simplified IPsec test bench the basics of the CLI and Linux-based management. So this is a very simple platform. You see we have 2 hosts that will be acting as the enterprise sites, and in between 2 security gateways that will encrypt the traffic and represent the edge security gateways. So I'm going to open the consoles on the first host, console on the first security gateway, on the second security gateway, and on the second host. In this test, we use SVTI, Secure Virtual Tunnel Interfaces, to encrypt the traffic. So the traffic will be generated from host 1. It will be routed through the first security gateway. On the security gateway, thanks to routing, we will go through the SVTI interface, where the traffic will be encrypted according to the security policies and security associations we will review. it will be sent over to the second security gateway to be decrypted and forwarded to the second host. Let's have a look at the configuration of the first security gateway using the CLI. So we have an industry standard CLI with help, completion, and contextual help. So here I'm editing my configuration. I'm going to check my first interface on the LAN side. Using the show command, I type question mark and I see the different possible commands. Using display question mark, I can see also what's available. So here, display, I see my IP address configured on the first interface. Display XML allows me to see the same configuration in XML format. This is very useful for automation and interaction with external tools. So this was my IP address on the LAN interface where I will receive packets from the first test hosts. Let's have a look at the SVTI interface, which is the secure interface that will be used for encrypting the traffic. We see this interface has an IP address, and also it has the addresses of the two encapsulating endpoints of the tunnel. Let's look at the routing configuration. We see the route towards the second host going through the IP address of the SVTI interface, which will make the packets go into this interface to be encapsulated. Let's go into the security context. Here I'm going to increase the size of my screen so you can see the security configuration. There we see the VPN that's used to encapsulate the traffic. We see the security associations that describe in details the protocols used for the crypto algorithms used for the encryption. And we see also the rules that are used to make the traffic match the VPN. So with this configuration, we are all set to encrypt the traffic coming from host 1 towards host 2. If I exit the configuration, I can also check the status of the system. So what we just reviewed was my intention to configure the system, and now we can see what's actually configured in the system. So we see the addresses of the interfaces. So for example, on the SVTI interface, we find this IP address we've seen previously and the encapsulating endpoints. Another example, look at the IPsec security associations. We see the different security associations. So if we just take one as an example, the one that will encrypt traffic between my two security gateways, and we see all the parameters of the security association. So we've just seen on the first security gateway how the IPsec is configured using SVTIs, and we have reviewed that with the CLI, the XML configuration, and we have also shown the status of the system. Interestingly, in 6-Win vRouter technology, we use Linux, and we support Linux-based configuration. So on the second security gateway, I'm going to log in as the root super user, and we can actually review exactly the same configuration. So I can check the interfaces that are configured on my system. And so I can check the address on the LAN interface connected to the second host. I can check the routes on the system. I can check the security associations, security policies here, and security associations. And so you see the Linux configuration matches the CLI configuration, and both management interfaces are available to the user. So that's it for the demonstration of our management. Just very quickly, let's generate some traffic. So the purpose here is to illustrate functionality, and I use an emulated environment, so we won't expect very high performance. Anyway, just to show it's a live system, I've started on my server the iPerf application, which is a TCP traffic generator. So I'm listening on the server on host 2, and on host 1, I'm generating traffic with the right destination and source IP address. Before I launch the traffic, on the security gateway, I'm going to use the show traffic command on the CLI, which takes an interface as an argument. So I'm going to dump the traffic on the one interface where we will see encrypted traffic. And because a lot of traffic will be generated, I will only capture 10 packets. Let's generate traffic. And let's see, on the security gateway, we see the traffic after some ARP resolution. The traffic is encrypted using ESP and encapsulated with the addresses we have defined on our SVTI interface. So that concludes our quick demo of a simple IPsec platform with the management using CLI, XML, and the Linux shell. Another way to manage the system is monitoring. Thanks to our Yang-based KPIs integrated with InfluxDB and Grafana in this screenshot, we monitor network throughput, IPsec statistics, CPU usage, and other detailed statistics. The integration of 6WIN vRouter with Grafana and InfluxDB is documented on GitHub, and our dashboards are public. They can be easily extended for specific use cases. So to conclude this demo, let's summarize what we have seen. 6WIN Turbo IPsec is a high-performance IPsec VPN software appliance that runs on COTS servers. It provides 10, 40, 100 gigabit per second connectivity, raw IPsec performance of 12.5 gigabit per second per core, and full-featured VPN performance of 7 gigabit per second per core in our use case. It comprises a complete security feature set with VRF, stateful filtering, as well as resiliency features at port and system levels through link aggregation, VRP, and IPsec HA. It can be managed using low-level Linux commands, traditional CLI, SNMP, syslog, and IT-style management through APIs for integration with orchestration tools. And finally, 6WIN vRouter can run as bare metal and also in virtual environments as a high-performance VNF. Thank you for your attention. Let me now turn over to Eva for a wrap-up and to announce the winner of our contest.
Thank you, Jan. Let's answer the questions we received. So the first questions we received is, how do you price your vRouter software?
Eva, I can take this one.
I don't know, maybe Kelly, you want to reply, you want to answer to this question?
Yes, great question. So we offer subscription and perpetual license options for our software. And our licenses are available starting at 1 gig packages, going up to 100 gig packages, depending on the customer's performance requirements.
Good. Another questions we received is, are 10 and 25 and 100 gig NICs supported? Are you able to fully saturate these NICs with your router and IPsec solutions?
We can give that one to Jan.
Yes, sure, I can take this one. So yes, we support 10, 25, 40, 50, and 100 gig NICs. We support all the recent NICs from Intel and also from Mellanox with the ConnectX series, and from Broadcom with the NetExtreme E series. And we can saturate these NICs with both router and IPsec solutions. We regularly demonstrate that kind of performance, and you can check some videos also on our YouTube channel where we show this performance.
All right. There is another question. Is CLI or Linux commands preferred for management?
Yeah, I take it. So I would say it's up to your use case. We have customers that use the traditional CLI for direct access to the vRouter. Some customers that prefer Linux, for example, because they already have a Linux management or because they integrate with tools that rely on Linux management. So for us, both work and both are supported. We also have our APIs for the configuration of the system with Yang-based models.
Have you tested the new Purley platform from Intel?
Yes, we have tested with Purley, and we generally test with the latest platforms, so CPUs, motherboards from the vendors we support. That's part of our products to always support the latest CPUs and NICs. So we have detailed results on Purley available on request.
Can this vRouter be interfacing our AWS Direct Connect?
Yes, so we support multiple virtualization and cloud environments with vRouter. We are able to deploy vRouter in an AWS private cloud, and we are working on public cloud deployment as we speak. So feel free to come to us to discuss more about your Amazon needs.
Another question about the monitoring is Grafana the unique tool to monitor the vRouter?
So Grafana and InfluxDB are examples of what can be done with the vRouter. The vRouter can be integrated with other monitoring and analytics tools. So, for example, we have done some work with the Elastic stack recently. So basically, we have Yang-based models. We have our KPIs modeled as Yang, and we are able to retrieve them using netconf, using APIs. And so it's just an example. So we've done the integration with InfluxDB. You can check that on GitHub and see the details, but it's possible to integrate with other tools.
Great. So we have a question about evaluation. So maybe Kelly, you want to answer this question?
Yes. So the question I see is it possible to evaluate our software? Oh, the answer is absolutely. So on our website homepage and all of our pages, by the way, you see an eval button. Simply fill out the form and which product you'd like to evaluate, and a local representative will be back in touch with you in a very short amount of time and set up the process with you.
All right. So another questions we have is, how is mixed CLI and Linux administration handled? For example, if a change is made in Linux, does the CLI reflect the change?
So the policy for this, it's a good question, is that you use one interface for configuration, and this is reflected for monitoring in the other interfaces. So if you start configuring your system using Linux and start modifying the configuration using Linux, you can use the CLI to monitor the system, to dump information about the system, but you should continue to use Linux for all the configuration. And conversely, if you use the CLI for the configuration, you rely on the CLI. So we have seen this requirement to be able to to monitor using different management interfaces, which makes sense because sometimes you integrate with different tools that already use Linux, and you don't want to integrate with the CLI. And so far, our customers focus on one configuration interface, the one of their choice, CLI, Linux, or APIs.
We have a homegrown system for provisioning and management. How could we integrate your products in our system?
Yes, so we provide, so that's a broad topic. We provide different interfaces. There is first deployment. So for deployment, we are a Linux-based system. We support cloud init. And so that's the interface that's available for provisioning in the systems. In bare metal, we can also use Pixie. And for management, so for configuration, we support netconf, CLI, restconf, and Linux-based management. So that's depending on the management system and the integration capabilities of the system. And for monitoring, so we have let's say legacy monitoring features like SNMP, like syslog. So these are very traditional and available in almost all monitoring systems. And we also support, let's say, more, I was going to say modern, but let's say IT style monitoring systems with analytics like we have seen with Grafana. So for this, we have the APIs that give the right information, so the right KPIs to the monitoring systems.
Is there any documentation available online?
I can start this one. So yes, if you go to our website and check the resource bar at the top, you'll see an option for our documentation. Here you will find the documentation for our vRouter software.
Next question, can it be integrated with different control planes like OpenControl?
Yes. So if you remember the beginning of Kelly's presentation, the vRouter comes with several flavors. So we have pure binary software that gives the first level of integration. So the software can be controlled through standard Linux APIs. So you can integrate, for example, a Turbo router. On the Turbo router, you can integrate your own control plane. And for customers that have very specific needs, so that want to go even further, we also provide our software in source code so that they can do their own modifications and can integrate very tightly with their own data plane and their own specific control plane.
Excellent. And one last question. Should we have to engage with 6WIN for evaluating the vRouter, or is it free of charge?
Oh, so I can take this as a similar question to the previous. So please do go through our website and fill out the evaluation form. That way we can assign the right representative and take care of your specific requirements.
Okay, this is all we have for the questions. So if there is no more question, we can move forward. So if you like what you saw in our demo and would like to evaluate 6WIN's vRouter for a new project, a Brocade replacement, or any other requirement, please submit your request in our online form at 6WIN.com. On our website, you will also find our product information, regularly updated blog roll, and registration for our monthly webinar series. You can also contact our regional sales VPs directly to set up an appointment, and we have their contact information right here. We also have a local representation at the upcoming HONORD conference in San Francisco and 2 webinars scheduled for May. Now, for our contest winner, it is time for one of you to win our high-performance remote control car. And I'm pleased to announce that the winner is Jonathan Hudspeth. Congratulations, Jonathan. We will be in touch with you after this webinar to coordinate the delivery. The webinar is now ending. Thank you for your participation, and we hope to see you again soon. Thank you.